Valve checks. A lot of the controllers allow you to stop the well to see if we're having a load loss, and then that load loss can be converted into barrels per day loss. So now if your operator comes up and his run time's increasing, the first thing you ask him to do is do a quick valve check for me. And let's just see, is that pump leaking and how much is it leaking before we need to decide we should pull the well. Well, once it hits 100% run time, you better think about pulling the well because you're leaving fluid. All those cycle times are saved in these controllers so you can look at your own off times. What's important here if the thing is just running its downtime and what we call the minimum pump time. So when a well starts up, you give it a little ignore time to fill. If it's just running on, off, on, off, on, off, something's not right. You've not got it set right. Something's going on, and that should alert you. Most all of these have a lot of data stored in the controllers, but most controllers, to save money, only keep about 60 days of data, and then they ask for the rest of the data to be stored up in a host system or a SCADA system that we bring the data in through a communication device. Most all of them are smart units, so they can tell you and save data if the well's been stopped or not. You know, we've had a lot of things where a wild contract crew's running around working on pipelines and shutting wells off and on, and you don't know it. You'll know it with these systems. You can wire HOA up. So if anybody turns the controller off, you can get an immediate alarm and you know exactly what time it happened. So when the guy says, oh no, we didn't turn it off, well, mystery, huh? One of the things that you'll learn more about over the next few days, again, is the accuracy. If you don't have the correct data, it skews the surface card, which means we calculate an incorrect downhole card, and you won't see the right fillage. This is one from our friend Mr. Savinos back there that he talks a lot about, of incorrect data, that when you had the original data, you thought you may have had pretty good fillage, but when you got it corrected, that well was very pumped off. And we've seen a lot of this with the older products out there that they really need to be calibrated and taken care of. Radio systems. We use a little bit of cell phone, a little bit of satellite, but those are all monthly charges, and most people don't want that fee. So we've gotten away from hardwire because you got all these backhoes running around out there digging wire up, and that never seems to last very well. So most systems are on radio. Now, we used to always use a fixed frequency. So that means we had to go to the government, go to the FCC, and get permission to use a certain license. Not easy to get, not many available. Well, not too many years ago, spread spectrum became available. And this was a military that was developed under the military during the war so that we could talk to each other without anybody listening in. And what it does, it changes frequencies within milliseconds between the radio so that you can't keep up with the frequency. And the FCC allows us a block of frequencies that we can use. So we can go out with a spread spectrum radio with no license and put it into your fields. But these systems typically, they're about a 15-mile span, but a spread spectrum radio can use a repeater so we can repeat them on. To do most of these systems, what you need to get the radio manufacturers is the GPS coordinates of where do you want your base radio and the GPS coordinates of your well sites. And with that, they can calculate what they can do for a system. Now, normally you're going to have two types of antennas. An Omni usually looks more like a stick. That usually creates a round area or maybe an egg-shaped area that we can hit with the radio system. The Yagis are directional, and those usually go at the well site. And they create a band of about 35 degrees. So we've got to point that antenna at the base antenna. Surge protection, again, very important in radio systems, that things are grounded and we have proper surge protection. This is a topographical map that with those GPS coordinates, the radio manufacturers can look at, is it really flat? You even think West Texas is flat? It's not really flat, guys, in some areas. We really do have issues. And radios are line of sight. If we've got something in the way, we've got to go around it. Now, the old frequencies, we didn't have to do some of that. Some of y'all are way too young to remember the old AM radios. I'm sure Dr. Podio can live to this story that you're going down the road with your old AM radio and you're down here in Texas and you pick up a station in Michigan or something. And that's called skip. You have that with the old frequencies, that the lower the frequency, the more interference and the more it can bend around things. The higher the frequency, the more direct line of sight. SCADA systems, supervisory control and data acquisition. There are several programs out there that talk to all of these controllers nowadays, and each controller has a protocol. So that's the language it speaks. I'm sort of a mix of South and East Texas. So if you had a guy from Louisiana like Mike here, our accents on a computer, it wouldn't understand it. So you got to have protocols that explains what is in that controller and what method it's talking. And most protocols are accepted by a lot of the control programs out there, but there's only a few programs available that show you dynamometer cards and work with it. It's sort of a niche. So how these all work is we again bring the data back in from whatever you have at a well. You can go into full networks, you can go into a simple computer system, you can take it up through the internet to where you could have just a client on your computer looking all the way back at that well of the data. So every bit of data that's in these controllers is available through these host software packages. The only thing we won't let you change is the radio address. Because if you change that in the computer and you get it wrong, now you're going to have to drive to the well and change it locally, or you'll never know what you're talking to. So what is all the goal behind this? Well, if you look at a normal well, your production's always falling off, and that's really your revenue line, and you've got a certain lifting cost. So there's the money you're making. With these control systems, we have proven we can increase the production and you can lower your lifting costs. So that just extends the life of that well. And that is it for rod pump control. So questions are available except for Jim Lee. I know you got a question, Lynn. I feel it coming.
Where'd your breakdown come from?
Spears. That's been, they update it every year. It's changed a few percent. If you look at beam pumping is losing a little bit every year. And it's ESP and PCP have both grown slightly. You know, there's charts out that will show you for these type of wells in production, this is the type of lift method you should use. And then all those lift methods have a little bit of overlap of what may or may not make sense. I'm ahead of time. Thank you.